Of course, the coal-fired complex is just one chapter in GRDA's story of power production and economic development in Oklahoma, and much of that economic development success is the direct result of GRDA's status as a public power utility. In fact, GRDA is one of 2,200 publicly owned electric utility systems in the United States today. Together, these systems are serving almost 35 million people in every state except Hawaii.
Public power is something that we can pass on to the co-ops and things like that, like Pryor, Clamor, Wagner, and so on, which helps those people to have a low cost of power where they can operate their communities in a fine way so that we can understand that public power is helping the people of Oklahoma.
The public power concept runs throughout the GRDA system because GRDA sells electricity to several Oklahoma communities which also own their own electric distribution system. And while all public power utilities are not-for-profit, the funds they generate from electric revenues help to support other services in their communities. Police and fire services, parks, and streets are all areas that benefit from low-cost, reliable Oklahoma public power, and GRDA is proud of the role it plays in that process. It all began for GRDA in 1940, following the construction of Pensacola Dam, and the utility has been supplying Oklahoma with reliable, abundant power ever since. The dam is one of the longest multiple-arch dams in the world and holds back the waters that create Grand Lake of the Cherokees, considered by many to be the region's premier recreation destination. For 70 years, the dam's existence has been the foundation for a thriving economic and tourism industry in northeast Oklahoma. In the early 1960s, GRDA also constructed Robert S. Kerr Dam and Lake Hudson to add even more renewable generating capacity. Soon after, the Salina Pump Storage Project, a hydroelectric facility located on the Saline Creek arm of Lake Hudson, was added to the system. While these facilities were all in place by 1972, GRDA still needed additional capacity to meet growing customer demands. So with approval coming from the Oklahoma legislature, construction began on the coal-fired complex in the late 1970s on a 1,245-acre site located adjacent to the MidAmerica Industrial Park. Unit 1 was completed in 1981, Unit 2 followed in 1985. GRDA also added natural gas generation to its portfolio in 2008 with the purchase of the Redbud plant. However, the coal-fired complex remains the primary source of power generation today. If you are visiting or working at the GRDA coal-fired complex, please be attentive to safety. You must follow instructions of your GRDA guide, such as wearing hard hats, hearing protection, and sturdy shoes. Also, please be alert to avoid tripping and overhead hazards. Stay on walkways, observe posted warning signs, and take extra care when descending stairs. And please do not touch operating equipment.
We certainly hope you've enjoyed this closer look at the Grand River Dam Authority's coal-fired complex. Thank you for taking the time to learn more about this important Oklahoma asset and how GRDA turns coal into electricity and how that electricity powers Oklahoma.
Whether it's your nightlight, your alarm clock, your computer, or your morning cup of coffee, it's all powered by electricity. And at the Grand River Dam Authority, we're in the business of generating that electricity to give you the power.
Hello, and welcome to the Grand River Dam Authority's coal-fired complex, where every day our mission is to generate low-cost, reliable electricity for the good of Oklahomans, while at the same time we strive to be a good steward of the environmental resources under our control. Over the next few minutes, let's take a closer look at this facility and see how we turn coal into electricity.
The GRDA coal-fired complex employs a workforce of over 200 in many highly skilled positions. This includes mechanics, welders, electricians, machinists, equipment operators, computer technicians, engineers, administrators, and much more.
To keep this facility operating takes a very diverse workforce with many different skill sets and people with different knowledge. Some of our best candidates, graduates from the Oklahoma Vocational Institutes. Some of the skill sets that are required are instrumentation skills. We have very large computer systems here, programmable logic controllers that the instrument department and those those personnel are responsible for maintaining. Our electrical department has a very diverse field, from digital controls to large electric motors as large as 9,000 horsepower. Our mechanical field takes care of all of our pumps and valves, and many of our pumps, turbines, are very high speed, very critical as far as maintaining proper clearances and proper installation techniques. This is the type of training and skill sets that we need to ensure this plant is maintained and operational and reliable for the years to come.
These are well-paying jobs, many of which are becoming more technical than ever before as the facility continues to adapt to the latest innovations designed to improve efficiency and enhance reliability.
Whether it be on the turbine, the boiler feed pumps, precip, you're constantly doing different things. And that makes your day go faster, and it's a lot more enjoyable because it's not the same repetition every day.
All day, every day, this workforce takes an abundant energy resource, coal, and turns it into the electricity that helps to drive the economy of Oklahoma. Meanwhile, the jobs created by the existence of the coal-fired complex also create tremendous economic benefits for the state. And here at GRDA, we believe that generates opportunity for the future.
Just exactly how does a workforce of 200 plus employees turn trainloads of coal into megawatts of electricity? Well, over the next few minutes, let's take a detailed look as we follow the coal from the coal train through the coal yard, into the plant, and out to the switch yard as megawatts of power.
Coal trains, owned by GRDA, transport the coal to the plant site. Upon arrival, GRDA personnel use a rotary dumper to unload the trains. Without ever removing the cars from the train set, the dumper can turn them upside down, one at a time, to dump coal into an underground storage area.
Coal comes into the plant through train cars, and our equipment is designed to dump the train cars. Then it's sent up to the plant, and any excess coal that we have that we don't need to coal the plant, we send out to the yard transfer, and we stack out on the coal pile, and it's used for storage when we need it. We can reclaim it with our stacker reclaimer. My men and myself, we're here to maintain all the equipment to make sure that dependability of the plant is maintained and that the plant is kept coaled up.
After the coal is unloaded to the storage area, it is then moved via conveyor belt for dispersal into silos. From there, large crushers inside the plant grind the coal to the consistency of talcum powder to then be injected into the boiler for combustion. Huge fans located below the boilers provide the air for combustion of the coal. The result is a large fireball inside the boiler. Miles and miles of steam piping surround the fireball inside the boiler. This piping is full of water, which GRDA pulls from the Grand River and sends on to the boiler only after it is treated and filtered on site. Inside the boiler piping, the water is heated to produce steam at 1,000 degrees Fahrenheit and 2,400 pounds per square inch of pressure. That pressurized steam is then piped from the boiler to the turbine. As it is forced over the turbine's blades, the steam turns the turbine and the attached generator rotor at a constant 60 revolutions per second within a magnetic field. This action creates electricity at 24,000 volts. After the steam drives the turbine, it is piped to a condenser which consists of tubes full of cool water. As the steam touches the tubes, it condenses back into water. Then it is sent to the cooling towers where its temperature is lowered before it is returned to the boiler to start the cycle again. In fact, the cloud-like plume coming from the cooling towers in front of the plant is merely water vapor from this cooling process. Meanwhile, the 24,000 volts of electricity created within the magnetic field passes through electric transformers on the plant site and is stepped up to 345,000 volts. While that is quite a jump in voltage, it is necessary for transmission. High voltage is used for transmitting power because it reduces loss over long distances. And that's very important for GRDA because we transmit electricity across nearly 2,000 miles of lines in Oklahoma.